Assalamu alaikum wa rahmatullah. Welcome back in part 2 of Kinematics 1. At the end of this part, you will be able to identify the trajectory of a moving object. Before, let's remember the main ideas of the previous part. The position vector is represented by OM vector is equal to R of t vector is equal to x of ti plus y of tj. The distance between the moving point M and the origin O is given by the magnitude of the vector OM, which is equal to the distance OM equal to radical x squared plus y squared. The parametric equations of motion are x, which is equal to x of t, and y, which is equal to y of t. What is a trajectory? The trajectory of a moving particle is the set of successive positions occupied by this particle over time, or it is defined as the path followed by a particle. If the path followed by the particle is a straight line, then the trajectory is said to be a straight trajectory. If the path followed by the particle is a circle, then it is said to be a circular trajectory. And if the path is a parabolic branch, then it is said to be a parabolic trajectory. The equation of the trajectory is a relation which is independent of time between its coordinates x and y, and it makes it possible to determine the type of the trajectory of the particle. If the equation of the trajectory is in the form of y is equal to ax plus b, then the trajectory is a straight line. If it is x minus a squared plus y minus b squared is equal to r squared, then the trajectory is a circle of radius r and center a of coordinates a and b. And if it is y is equal to ax squared plus bx plus c, then the trajectory is a parabola. How do we determine the equation of trajectory? It is determined from the components of the position vector. But how it is found? Let's take the following example. The position vector OM is equal to 4t minus 1i plus 2t squared plus 1j. We have to follow 4 steps in order to find the equation of trajectory. Step 1. Write the components of the position vector, which are the parametric equations. The parametric equations of this motion are x of t is equal to 4t minus 1 and y of t is equal to 2t squared plus 1. Step number 2. Express the time t as a function of one of the variables of the components. That means time as a function of x or time as a function of y. In this example, we've expressed time as a function of x. From the first equation, we can find that 4t is equal to x plus 1, and then t is equal to x plus 1 divided by 4. In step 3, replace the expression of time variable in the other component. In this case, we have to substitute t, which is equal to x plus 1 divided by 4, in the equation of y, and that will give y is equal to 2 into x plus 1 divided by 4 all squared plus 1. And the last step, which is step 4, conclude the type of the trajectory by comparing the resulting equation and the standard equations of trajectory. Our resulting equation is y is equal to x squared divided by 8 plus x divided by 4 plus 9 over 8. By comparing it to the forms of the trajectory, we can find that it is very similar to y is equal to ax squared plus bx plus c, where a is equal to 1 over 8, b is equal to 1 over 4, and c is equal to 9 over 8. Therefore, we conclude that the trajectory in this case is a part of a parabola. Follow the same step for each given position vector to find the equation and the type of the followed trajectory. For example, if r of t is equal to ti plus t squared plus 1j, then the parametric equations of motion are x of t is equal to t and y of t is equal to t squared plus 1. By taking x is equal to t and substituting it in that second equation, which is y of t, the equation of trajectory will give y is equal to x squared plus 1. This equation has the form of a quadratic equation, which is y is equal to ax squared plus bx plus c. We conclude that the trajectory is a branch of a parabola. When plotting the equation of the trajectory y as a function of x, this graph is obtained, which has the shape of a part of a parabola. To see the path of this particle with time on this parabola, we find its coordinates at 3 different instants. For example, at time t is equal to 0, when we substitute it in the parametric equations, x will give 0 and y will give 1. Then the position of the particle is given as seen. At time t is equal to 1 second, the coordinates of this particle are x is equal to 1 and y is equal to 2. Notice that the position of the particle is changing. At the instant t is equal to 2, x is equal to 2 and y is equal to 5. Then the particle will move higher up in this parabola. But we know that the time variable is always positive. Then, knowing that x is equal to t, that x will be also positive. Therefore, this part of the parabola is not considered, and the correct part of the parabola is this one circled in green. Example number 2. R of t is equal to t minus 1i plus t squared j. The parametric equations of motion are x of t is equal to t minus 1 and y of t is equal to t squared. By choosing the parametric equation x of t, we find that t is equal to x plus 1. While substituting it in y of t, the equation of trajectory will give y is equal to x plus 1 all of it squared. This equation has the form of the quadratic equation. Then we conclude that the trajectory is also a branch of a parabola. To see the path of this particle with time on this parabola, we will follow the same previous steps. At time t is equal to 0, the coordinates of this particle were x is equal to minus 1 and y is equal to 0. At the instant t is equal to 1, x was equal to 0 and y is equal to 1. Then the particle moved to this point, and at the time t is equal to 2, x is equal to 1 and y is equal to 4. The particle moved up to this position. But we know that the time variable is always positive. Then, since x is equal to t minus 1 and t should be positive, then x plus 1 should always be positive. Then x should be greater or equal to minus 1. Therefore, this part of the parabola is not considered, and the correct part of the parabola is this one, which is circled in green. Example number 3. R of t is equal to cosine 2ti plus sine 2tj. The parametric equations of motion are x of t is equal to cosine 2t and y of t is equal to sine 2t. By squaring both equations, we will get cosine squared 2t plus sine squared 2t is equal to 1. The equation of the trajectory is x squared plus y squared is equal to 1. And we know that the standard equation is of the form x minus a squared plus y minus b squared is equal to r squared. By comparing these two equations, we can find that the trajectory is a circle of radius r is equal to 1 and center O, which has coordinates 0, 0. When plotting the equation of trajectory, y is a function of x, this graph is obtained, which is a circle of radius r is equal to 1 and center O having coordinates 0, 0. To see the path of the particle, we will follow the previous steps. At instant t equal to 0, the coordinates of this particle were x is equal to 1 and y is equal to 0. Then the particle has this position labeled on the graph. At the instant t is equal to pi divided by 4, by substituting t in x, it will give x is equal to cosine 2 multiplied by pi divided by 4, and it will give 0, and y will give 1. Then the particle will move to the other point having coordinates x is equal to 0 and y is equal to 1. To check our understanding, let us solve the following applications. Application number 1. The adjacent figure represents the launching of a rocket. The expression of the position vector is given by r vector is equal to om vector is equal to 2ti plus 4t squared plus 8tj. All variables are in SI units. Please pause the video and try to solve this application alone, then check your answers. In part 1, we have to determine the position of the rocket at time t is equal to 0 simply by substituting t is equal to 0 in the equation. We will get 0i plus 0j. In part 2, determine the parametric equations. We have to pick the parametric equations from the position vector. X is equal to 2t and y is equal to 4t squared plus 8t. In part 3, determine the equation of trajectory. Using the parametric equation x is equal to 2t, we can find that t is equal to x divided by 2, then substituting it in equation of y, this will give y is equal to x squared plus 4x. Application number 2. Given the position vector of particle m during its motion, r of t is equal to om is equal to 3 cosine 3ti plus 3 sine 3tj. Part 1. Determine its position at time t is equal to 0. We have to substitute in the equation t is equal to 0. We know that cosine 0 is equal to 1 and sine 0 is equal to 0. Then it will give 3i. In part 2, determine the parametric equations of motion. X is equal to 3 cosine 3t and y is equal to 3 sine 3t. In part 3, determine the equation of the trajectory of m and deduce its shape. Using the parametric equations, we can find that x divided by 3 is equal to cosine 3t and y divided by 3 is equal to sine 3t. By squaring both equations and then adding them and knowing that cosine squared 3t plus sine squared 3t is equal to 1, then this will give x divided by 3 squared plus y divided by 3 squared is equal to 1, so x squared plus y squared is equal to 9. The equation of trajectory is of the form x minus a squared plus y minus b squared, which is equal to r squared. Therefore, we can deduce that the trajectory is a circle of radius r is equal to 3 and center O 0, 0. Let us summarize now the main ideas of this video. The trajectory is the path followed by the particle during its motion. The equation of the trajectory is a time-independent relation between x and y, which allows us to determine its shape. If the equation of the trajectory is in the form of y is equal to ax plus b, then the trajectory is a straight line. If it is y is equal to ax squared plus bx plus c, then the trajectory is a parabola, where a, b, and c are real numbers. And if it is x minus a squared plus y minus b squared is equal to r squared, then the trajectory is a circle of radius r and center A having coordinates a and b. Thank you for watching this video.